You guys ever play the game, Where is Miss Carly Recording From? Well, today I'm sitting in my dining room with my kitchen behind me. I don't know why I'm sitting here other than there's nobody home, so it's quieter in the house. Good morning, geometry. We are in lesson 3 of unit 2. We're still in congruency. We'll be in congruency all unit. And today we are talking about congruent triangles, part 1. True or sometimes true is the question. So if triangle ABC is congruent to triangle A prime, B prime, C prime, what must be true? Okay, what must be true if those are congruent? First, let's draw some triangles. I thought I did that. Draw, yep. We're going to call this one A, B, C, A prime, B prime, C prime. All right, so what must be true? Well, we know that AB has to be congruent to A prime, B prime, and BC has to be congruent to B prime, C prime, and CA or AC has to be congruent to C prime, A prime. We also know what must be true is angle A is congruent to angle A prime. Angle B is congruent to angle B prime, and angle C is congruent to angle C prime. And we can actually know that from how it's written. We're saying triangle ABC is congruent to A prime, B prime, C prime. So if A is first, A prime is first, that's how we know those angles are congruent. B is second, B prime is second, that's how we know those are congruent, right? C is third, C prime is third, that's how we know those are congruent. All right, so the order they write things in is quite important. Same with the sides, all right? AB is first, A prime, B prime is first. BC is second, B prime, C prime is second. And then beginning, end, A and C, beginning, end, A prime and C prime. Those are written on purpose that way. So we could actually transform triangle ABC, C onto triangle A prime, B prime, C prime with a series of transformations. We can put one image onto the other with a series of transformations, okay? I'm just going to point out some other obvious things that we've talked about. These are all because rigid transformations. Yeah, I don't think that's going to work. Transformations. Oh, not good. All right, we're going right here. I'm sorry. I thought I set this up to undo. There we go. Let me start over. We know that the angles are congruent, and let's just be clear. We know that the sides are congruent, and I'll keep it in green so we can keep it together, because rigid transformations preserve distance and measurements. Okay, so that's why we know it. All right, let's look at what could possibly be true. Let's see. These are silly. What could possibly be true? If we said in number 1 that we just did a translation, this is number 1, sorry. We could say in number 2 that it could be a series of transformations. Oh, my dinner's getting done. Transformations. Hold on, pausing you for a second. Oh, maybe. I believe I just said a series of transformations. So possibly this could be a reflection and then a rotation instead of a translation, right? Okay, what else could be true? I don't know. The shape of the triangle could be isosceles, it could be scalene, it could be acute, it could be obtuse. I don't know. Like, we don't know anything about it, so anything could be true about that. And then what definitely can't be true? Talk about silly ones. Let's do red. Can't have four sides, right? And we're moving on. All right, let's look at this next section. It's called invisible triangles. So the goal here is for you guys to generalize the transformations that you've used in specific cases. Right, so this is a card swap thing. I'm going to read through it and then we're going to talk through it a little bit. So you're the transformer, take a transformer card. Okay, so that's player 1. And you're sharing a table with someone, player 2. Select a triangle card. Do not show it to anyone. Study the diagram to figure out which sides and which angles correspond. Tell player 1 what you figured out. Okay? And then player 1, again, would take notes about what they tell you so you know which parts of their triangles correspond. Think of a sequence of rigid motions you could tell your partner to get them to take one of their triangles onto the other. Be specific in your language. The notes on your card can help with this. Then player 2, listen to the instructions from the transformer. Use the tracing paper to follow their instructions. Draw the image after each step. Let them know when they've lined up 1, 2, or all 3 vertices on your triangle. All right, pause there for a second. I'm going to bring up this activity so we can look at it. So we talk through this. Excuse me, I'm not going to be able to write on it though. All right, so if you have your player 1 and you have card A, right? I can draw, but it won't stay, which is very annoying. So you have card A, I have the transformer card. Okay, so you're going to talk to me. So listen to hear which parts of the triangles correspond, then give instructions to take one triangle onto the other. So you're going to possibly tell me to translate, let's translate triangle ABC to triangle DEF by directed line segment CF. Okay, so we're going to translate that there. Now, I'm not sure if they'll line up yet because we don't have tracing paper, but once I translate this triangle to that triangle using directed line segment CF, I may have to rotate, because this will be where they meet, I may have to rotate triangle ABC counterclockwise until point A meets with point D, and then they will correspond. Then they'll be on top of each other. So first, I would translate. Then, from where they both meet here, I would rotate counterclockwise until A meets with D. Okay? So you could say translate triangle ABC from C to F. Rotate, yes, using C or F as the center by, we aren't going to measure the angle, we're just going to say until A goes to D. Or we could say until B goes to E. That doesn't matter. And then rotate using the blank as a center so it coincides. We don't have to do any of that. We don't have to reflect it. We don't have to reflect it. So corresponding are AC and DF. Those sides correspond because they're both triple marks. And then AB corresponds to DE because they're both single ticks. And then BC, and you know what? It doesn't matter what order you name them in. I could say CB or FE. It doesn't matter. So we just draw the sides, then we can say angle C corresponds or is congruent to angle F. Angle A is congruent to angle D, they're corresponding, and then angle B is congruent to angle E. All right, so that's all good. All right, let's look at the next one. Okay, let's see how we would